right, thank you. Thanks, John. Hey, everyone. Hey, everyone at 360 NDev. Welcome to my talk on writing amazing tech specs. So this is a talk on writing documentation, really. As odd as that sounds, that's exactly what this talk is about at its core. By the end of the talk, I hope you come out with an understanding of what like an amazing tech spec looks like, the benefits of writing one, and you're equipped to start writing your own to make you, your team, and your project more successful. Now, this is the first time I've given a talk at a conference, so bear with me for being a noob. All right, so who am I? My name is Onyx Mueller, and I've been building mobile apps for over a decade. I'm part of the sports technology org of Warner Media, and we're the folks behind March Madness Live and Bleacher Report, the suite of apps for mobile, connected, and voice. Now, this isn't the usual talk you'd hear at a conference like this. Like most talks are centered around the development phase, things like writing code, using frameworks, SDKs, tooling like Android Studio, etc. Some talks are focused mostly on the post-development phase, things like automation, CI/CD, shipping to the Google Play Store, etc. But there's not a lot of talks that focus on what should be happening in the pre-development phase. And this talk prescribes exactly to what should happen in that phase. Before writing any code to solve even the most trivial of software problems, a software engineer should really write a tech spec. So let's talk about a few scenarios real quick. Scenario one, you're about to launch a new mobile app. Let's say it's a new Android app that your team has spent months working on. When you try to verify a feature in staging, nothing works as expected. After digging into the problem, you discover that an API or a query that the feature was relying on has completely changed. Scenario two, a new feature that you built for your suite of apps, let's say across Android, iOS, and web. You're building a new feature for those platforms, but as that feature starts to take shape, you come to find that each one behaves a little bit differently. The user experience is different across all the platforms. Scenario three, while you're trying to integrate a new framework or library you need for a new feature within your suite of apps, you discover one of your platform engineers has been working with outdated requirements, nullifying weeks of their work. And lastly, scenario four, after announcing that your team is working on something new, you're flooded with requests to widen the scope of your project. Bogged down by new requirements, you begin to wonder, like, when is this feature actually going to hit production? I'm sure one of you all can relate to at least one of these scenarios at one capacity or another. When you distill those previous scenarios down to the fundamental issues, you come up with a list of challenges that look like this. The challenge of lack of communication or loss in translation. The challenge of having consistency. The challenge of outdated specifications. And the challenge of scope creep. So what do these challenges have in common? Each one could have been prevented or at least lessened by crafting an amazing tech spec. So what is a tech spec? A tech spec, which is short for a technical specification, is a detailed document that describes how a project or a feature will look or be tackled from a technical perspective. A tech spec is like a blueprint. No one would begin construction work on a building without detailed blueprint from an architect. Likewise, nothing should be built in the digital world without having something similar. A tech spec forces you to think through complicated issues and get everyone on the same page. Now, you might be asking yourself, WTF, more documentation? The very idea of a tech spec can seem contrary to Silicon Valley ethos. Engineers want to move fast, break things, rapidly iterate, be a doer, and do all the things now. Some engineers may regard writing a tech spec as an unnecessary process that gets in the way of the agile approach, a big waste of time. But the point of a tech spec is not to impede progress, but to take a brief step back and think things through. And having a thoughtful, well-written tech spec unlocks many benefits as well, too, such as knowing the unknowns. When the work is disseminated, you realize the possible blockers, potential issues like performance issues or issues around complexity, misfunctional requirements, possible risks, etc. Documentation. The tech spec serves as documentation both during the implementation and after launch. During implementation, it specifies exactly the work you need to get done. After launch, it helps uninformed engineers get up to speed quickly on the inner workings of something or the trade-offs involved. Consensus. Reaching consensus across stakeholders and engineers at the tech spec stage means less contention down the road, which is invaluable when you're under a crunch or trying to get a feature launch. And after launch, the tech spec serves as a valuable reference guide where stakeholders can quickly locate information like why certain implementation decisions are made, what the project scope is, and how it integrates into other platforms and services. Estimation and predictability of delivery. Because time was spent up front to think through the implementation, more is known. This translates to increased accuracy in estimation, and delivery can be more predictable. Faster iteration. Since more is known up front, then you can iterate faster through your project. Better quality and lower risk. In a similar vein to the previous points, the more that you know up front, the more that there's more that's exposed. Things are, you expose ideas to a wider audience. And because of that, when you have more eyes on this, you discover issues and potential problems earlier. I want to point to a chart here that I'm sure you've seen on the internet before, but essentially capturing issues earlier on in a project or a feature dramatically decreases the magnitude to solve it later on down the road. And the last benefit of a tech spec is the reduction in scope creep. So having a good tech spec and being able to lay out exactly what is being built up front and having stakeholders be on the same page makes it difficult to change that later on and have other folks tack on more scope. So in the following sections, I'll describe how to write a tech spec. I'll lay down some ground rules and define a structure template I like to use and go through that with an example. So defining purpose. So to maximize the utility of your tech spec, give it a purpose. Ask yourself, what do I want to achieve with this tech spec? Your answer will be the foundation of your tech spec. There are different purposes for tech specs, different starting points, different approaches, different contexts. All that factors into the purpose of a tech spec. Each purpose type will have a different level of detail and a different audience. For example, your tech spec's purpose might be to get help with open questions through an architectural review of a brand new service. Or your tech spec purpose might be to move a controversial approach forward and you want to get buy-in from stakeholders. As your project and your purpose evolves, your tech spec will too. Early stages of a project might call for a tech spec with high-level details to get buy-in from stakeholders. After the buy-in, the spec can transition to lower-level details needed for completion and delivery. So for the purpose of this talk, I will focus on describing what a feature tech spec looks like. So there's a wide range of software being built by a vast number of companies out there. Each organization is distinct and creates its own unique engineering culture. As a result, tech specs may not be a standard even within companies, within divisions, within teams, and even among engineers on the same team. Every solution has a different need, and you should tailor your tech spec based on the project. So from my experience, here are the essential sections of a tech spec: the heading, summary and background, goals and non-goals, implementation, debug testing, measurements, security privacy risks, other considerations, milestones, and open questions. So I'll talk through each section using an example feature that needs to be implemented. In my example, the feature that we're trying to implement is the Google Cast SDK, which is a framework that's used by mobile and web apps to be able to cast content on devices onto big screens that have Chromecast or some Chromecast capabilities. So the heading section, pretty straightforward. The heading should include the spec name, the authors or authors, the contributing team, and the date at minimum. Optionally, include reference links like a link to an epic, a ticket, an issue, or a task. So in our example, I use myself as an author, my team name, and a date. I've also included links to the product specification and the Jira epic as well that's associated with the work. The summary section. So the summary is like an abstract for your tech spec, the who, what, when, where, why of the spec made succinct. In our example, I keep the summary very simple. Remote media protocols like Google Cast enable users to stream video to the biggest screens in their home. The background section. So to provide a background, contextualize your project. Why build it? What is the motivation? What are the user problems you're attempting to solve? What previous efforts, if any, have been made to solve this problem? In my example, I wrote the background as so. Cast allows mobile and web apps to cast video to cast-ready devices such as Chromecast, TVs with Chromecast built in, and smart displays. Since its introduction, cast technology has become wildly popular. Having a cast-capable app has become an expectation for video-centric apps. The goals section. So highlight all the outcomes that you predict will result from your work, both purposeful and inadvertent. This is especially important when you're contributing to a large ecosystem of services and code. This section, along with the measurement section, are the yardstick by which you'll evaluate the success of your project. Did we achieve our intended goals and impact? So the goals of my example are to provide another screen to mobile users to watch video, increase video consumption, and integrate the Google Cast SDK into the mobile apps. The non-goals section. So I feel that providing non-goals are equally as important as the goals, but the concept of a non-goal can be unintuitive and confusing. I define a non-goal as something that you're intentionally not doing or solving with your project, even if it's related. Defining non-goals will help limit the scope of the project and will help prevent scope creep. And just like goals, non-goals should be entirely eminently readable so that they immediately jump out to reviewers when they're reading your tech spec, which is why I suggest using bullet points. So for our example, the non-goals are integration of Apple's AirPlay, integration of Amazon's Fling SDK, which if you're not familiar with, it's Amazon's answer to casting. I don't know who uses it really, but and support for audio-only casting. The implementation section. Now this will be the longest part of your tech spec. It is a product of most of your research and preparation. In this section, you'll describe your engineering approach with detail. Your level of detail will depend on your tech spec's purpose and its intended audience. Make it as descriptive enough to encourage productive suggestions. Now, this is a good place to include illustrations that show how your project interacts with existing systems. That may mean a flowchart representing the user experience or a diagram that's showing the data flow through the different services and databases. If your tech spec covers low-level topics, consider like including HTTP response codes or GraphQL graph codes, if you will, error codes, excuse me, data payload snippets and errors. Now, for the example, the implementation, in the example that I'm giving with the Cast SDK, it's a little detailed and implementation specific, so I did not include an example here. Next section is the debug and testing section. So this section should describe the testing strategy or useful functionality used for debugging or testing. A lot of people, when they're building a feature or working with a team and building their product, don't consider the people that they're building for as the user, another type of user. Even though they're like part of the same team or an admin user or an internal user, they should consider those folks and try to think of the good ways to test the functionality and maybe provide some hooks within the apps to provide that. So in this section of the tech spec, this is a great place to provide those kind of call outs. So for example, I just say, provide a means to switch between staging and production cast receiver apps within the mobile app. The measurement section. This section defines specific metrics that you expect your project will impact. They should map directly to your goals. In the early stages of a project, these metrics can help answer difficult questions around prioritization. And after launch, they become means of gauging the project's success and identifying areas of improvement. I'm of the opinion that you can't ship any feature without having measurements. That is a part of the feature to make sure that you can verify that that your feature is doing what it needs to do. And that can be at like an analytics level, but that can also just be as simple as making sure that a user is pressing the button and it's being used as intended. So for our example, I just kept the measures real simple. That one of the goals is to measure that video consumption is increased by 10% within 3 months of launch. The security, privacy, and risk section. So providing the insight into security, privacy, and risk in this section. If your project is external facing, list all the ways that malicious users could exploit your change. Highlighting these risks can be very anxiety inducing, but you might be thinking, what if reviewers criticize you for introducing all this risk into the system? Still, it's important to solicit these critiques so that reviewers can pose questions and solutions that will ultimately make your feature more robust. So the security note added in here is that a very real thing that on iOS 14, applications that scan for devices on local network require permission to do so. And so therefore, if users block that permission, they won't be able to cast. The other consideration section. So discuss approaches you considered but ultimately decided against in this section. This serves as like a form of documentation that can preempt suggestions from reviewers to investigate approaches you've already thought of and discarded. So for our example, the other consideration here is that the integration of the Cast SDK into the web was considered, but ultimately decided against because it was a low return in investment. The milestone section. So to keep your project on track, call out key accomplishments and assign estimated dates. These could be checkpoints when significant chunks of work have been completed, or metrics to indicate the passing of a milestone. I added 3 example milestones to our example. Cast receiver development and deployment is complete by August 1st. The Cast sender development is complete by August 15th, and everything is QA complete by October 1st. The open questions section. So in here, you want to list unresolved design or implementation questions along with an invitation for reviewers to give feedback. Feel free to call out specific people or groups that might have valuable input into this. This is the last section of the TechSplit template, and we'll switch out here. So the only open question that I added to our example is, how will we introduce Cast functionality to users or new users of the app? All right, so now that we've gone through a trivial example of writing a tech spec, I have a few comments on the writing process. So first off, know that writing is a skill and it takes practice and discipline, but it's worth the effort. Improving your communication skills is essential to becoming a clearer thinker and a better leader. Your first tech spec will be slow going. You just need to do it and then do another and another. It gets easier. Try writing with the door closed. Write your first draft without any distractions, clear your calendar for several hours, turn off Slack, silence your phone, tell people to leave you alone so that you can focus and write out what's in your mind. Don't revise too much. Just get your thoughts out there so that you have a consistent narrative of because X, we do Y, that kind of thing. Rewrite with the door open. Once your raw thoughts are out there, it's time for collaboration to begin. Share your drafts. Get feedback, go back and fill in the missing details. Be transparent about how you're updating your technical proposal as you make discoveries. Feedback. So after the tech spec is in a reasonable finalized state, publish it. Now it's time to get some feedback. Start by asking your internal teammates for an initial review before distributing the tech spec widely. They can catch glaring errors, omissions, typos, things like that. Then send your tech spec to wider audiences. First, your greater team, then to stakeholders, and finally to all interested parties. With each round, your spec becomes more refined and more appealing to reviewers. Most comments warrant a response, so be sure to have one, whether from you or from another reader. When an issue is resolved, note its resolution explicitly in the comments or in the text spec itself. Engage with your readers and reviewers. They want to help you build the best possible product. So some advice on the process. So start with a template. I've included a link to mine in the reference section in the next slide. Use a collaborative document editor that everyone has access to, or use a markup language that the team is familiar with. The March Madness Live team uses Markdown. It's easy to read and easy to write. Documentation is only as useful as it is accessible. At March Madness Live, we store the collection of tech specs in a GitHub repo. Any engineer can view and contribute to the tech specs. Moreover, GitHub makes it really easy to version specs and see changes. Also, GitHub makes it nice when you have like a pull request to have a nice conversation about the tech spec with the person who authored it or the reviewers involved. Provide a place to have a conversation around tech specs. Similar to what I just said with doing this within GitHub, we have a dedicated Slack channel as well that we discuss tech specs and make stakeholders aware of new specs or changes to existing ones. So lastly, I've created a little reference page. I've created an amazing tech specs repo and put up and made it public and put on GitHub. It contains a tech spec template that can be used as a springboard for tech spec authoring. It also has an example, the example tech spec that I referenced in this talk around building a CAST integration into your apps. I'll likely update this over time. So a tech spec will increase value and increase the chances of having a successful project and feature that all stakeholders involved are satisfied with. I hope my talk has convinced you to join the minority of folks who invest time into crafting great tech specs. Why? Because tech specs are an upfront investment and time and effort that in the long run can pay exponential payoffs for you and your team. So with that, thank you for listening and happy tech specking.
Well done, sir. Well done.
Thank you.
All right, so we've got a little bit of time. If anybody has any questions, feel free to unmute and ask on cam or hop into the appropriate Slack channel and throw your questions out. You can also just ask the questions there anytime later on, and Onyx can get to them if you are not questionful right now.
I have a question.
Sure.
Great talk, Onyx. My question is, how long until, about the longevity of the tech spec, how long does the tech spec has to be maintained? And whose responsibility is it? Is it entirely developers or PMs, or do they both of them work together on it?
Yeah, great question. We're in year 2 of this, and this is going to be a big step in our evolution to figure out how we evolve a tech spec along with the feature, right? You ship a feature to the store, but then your feature, product team decides to evolve that feature slightly. They make some tweaks or changes, and so that needs to get massaged into the tech spec. And so we've been talking about a lot of this and how to approach it. I think to answer one question, the person that owns it is usually the author or authors that you put in that heading of the tech spec. And ultimately they're part of a team that can also help as well. Within our group, we have a team of what we call architects, but they're also responsible for the tech specs as a whole and understand the whole system and how things work and all that. And so any one of those folks on that team can help with that. But yeah, so part of the process that helps with the maintaining is making sure that the inputs are maintained as well. So product is updating their product functionals, design is updating theirs, and that you can track some form of deltas from the product requirements or from the designs that you can then convert and update into the tech spec itself. And then once you've updated tech spec with those changes and maintained it, like I mentioned in my talk, we use GitHub to notify a whole team of GitHub related folks that, hey, there's this new set of changes to this tech spec, read it, understand it, ask any questions. And once that's well understood and we're ready to bless it, if you will, then that drives a new set of technical tickets that those teams go and create, within their Jira and whatnot.
So it's like a ever living like a embodiment of what your project does or what your application or whatever it does, and it's like in a constant state of updates. Anytime you make an update, you go back, revise it, and put it in.
Yeah, more or less. I think with March Madness, it's more of a tentpole event, and it happens one time a year, and so it's not constantly evolving. But for folks that develop software that are constantly shipping to the store, yeah, if you're touching that feature, then yeah, it's constantly in motion. I would expect for sure.
Sounds good. Thank you.
Awesome. We've got one from Slack. James asked, how do you version your revisions?
Yeah, great point. So one way that we version things year over year is just because we have it in a GitHub repo, we can tag it and say that this was the 2020 what was delivered in 2020, and then we can go back to that tag at any moment in time. So that makes it easy with that particular tool. But everybody's tooling is going to be different. Maybe not everyone wants to do it in GitHub, and so having like I mentioned in the talk, having a good collaborative editor will usually have some kind of commenting or annotation system that allows you to do something similar, I would expect. So it helps with that regard. The other thing is by using GitHub is that you can reference a commit. So so maybe you could pull that commit out and drop it into the product requirements, that this product requirements matches this technical document at this commit hash, that kind of thing.